Okay, in this video we're going to break down this lever sub assembly, rotary lever sub assembly. So over here there's several parts. There's a nut on this side, there's a washer, there's a tapered pin with lug head. Over here you have a spindle, you have a square key, you have the lever, there's another washer, there's a stud, and then there's a planety lever. Now, one of the challenges with this drawing is that you're only seeing one view of parts. So they're not showing you like a secondary view, and there's a reason for this. So the skill that you need to understand before you can really get this drawing done in its entirety is, how can I draw this piece when I'm only seeing one view? So that is what we're gonna go into first. So I'm gonna draw the spindle. Now the thing about this spindle is they have given you all of the vertical measurements. So I'm just gonna draw a line going up to the center, and then I'm gonna start with just a random horizontal line. So for this line, I'm going to keep this line here by this bottom piece of the spindle, which is 25. Now you realize that it has diameter 25. So all that means is that the shape of this spindle, the bottom part of the spindle here, is a circle because it has diameter 25. So if I had to just use lines, change my layer to a text layer, and I would come across, since it's diameter 25, I would have to divide that measurement by 2, so that half of the 25 is on the left side, which is 12.5, and I'm putting half of the 25 on the right side, which is another 12.5. So this is the bottom part of the spindle. So when I go to dimension it, I realize here that I have my 25. I'm just going to change this to dimension. So you can see there we have our 25. The same thing applies for the 32 above. It is diameter 32. So the shape of this piece that is here is actually a circle. It's a cylindrical shape. If we had to look down at the figure, we would see a circle because it has diameter 32. For this one though, I'm not going to draw across the half. For this one, I'm going to offset it. So I'll delete this. I offset. Half of 32 is 16. So I offset to the left, offset to the right. So now I'm going to dimension. And let's just see if that is indeed 32. See, it's 32. And it says here that there's a 3 going up. So I'll offset that 2, offset 3. And now I'm going to trim. So I have my 32, I have my 25. Now I have this other piece here. And the thing about this piece, you're not sure what the measurement is because they don't give you a diameter, they don't give you a lateral measurement, a length going across. But if you take a close look at this drawing, and I'm going to pull this piece, well, I'm going to use my AutoCAD window to measure it. So when I pull this across, I can see here that I'm by my 32 here at the bottom. So I'm just going to pull this across to see where this piece lines up to. You see it lines up directly with that hidden detail above. It lines up directly with the hidden detail above. And the shape of this piece up here is 22. So let me just check the right side. It lines up directly with the 22 above. So a shape of the size of this is actually diameter 22. So that means from the left side to the right side is 22. So when I come, I want half of 22, so I'm going to offset 11, 11 to the right, 11 to the left, and now we trim. And that 22 piece goes up 25, so offset 25. I'm just going to clean this up. Now we have this piece here that has M14. So this M14 that we're going to have, we know that that diameter, it means diameter 14. So we offset 7. 7 to the left, 7 to the right. And we are going to come up here to 2. And then we have our 14. Our 14 comes up 20. So we're just going to draw in this bump here. We'll probably bring that down about 2. And we do a 3-point. Trim. Down here. Now, there's no particular size for the curve in here, but usually on drawings, it would tell you that unspecified curves are a particular measurement. And it comes here and it says all fillet and small radii are 3 millimeters. Use your judgment where dimensions have been omitted. You're not to show hidden edges or dimensions on your drawing. So for this drawing, they don't want you to show certain things, but it tells you that unspecified radii are 3, or you use judgment. So we're going to use our judgment. So the radius 3, I'm going to come here. Now I could simply use a fillet, but I'm not going to use a fillet. If I come here diameter 3, you realize that that is too big. So I'm just going to put it there at diameter 2. Radius 2, sorry. Alright, so now we have this piece that is here finished. Now, if you wanted to draw in that bottom piece, you'll probably come and use a spline, and you just come and draw in this piece here. The great thing about a spline is it's just a curve. So we have another spline, and we'll trim. So here's the piece, here's the spindle. Now the spindle has in this 15 piece for a square key. Now what a key is, a key allows you, a key is a fastener. So what a key does is usually it will fit into a cylindrical hole. So you realize that there is a slot cut out in this spindle, and there's a slot for this square key that goes right into it. So what would happen is, if we want to put this spindle into the lever, you realize that there's a hidden detail portion here. There's an extra hidden detail. So when we push in the spindle, we want to make sure that the spindle is locked inside of the lever. Now we can lock it by using a nut at the top and a washer that will hold it in place. But the problem may be that because the spindle is a cylinder and it's going inside of a cylindrical hole that does not have any threads, this spindle may turn. So let me just go over that again. This is a smooth hole. There are no threads inside of this hole. Unlike this hole to the right that has threads, this is a smooth hole. So when we push the spindle inside, the 22 part which is here fits smoothly into this piece. So there's nothing to stop this spindle from spinning or turning left and turning right. When we put the washer on the top, when we put the nut on the top, that only locks the top part of it. But the whole assembly of the nut, the washer, and the spindle inside of the lever, it can turn left to right. So to stop that movement, we're going to put a key in it. We have the slot cut out here in the lever. We will drop in the key. Once we push in the spindle, you will push the key inside, and that will hold the spindle in place so that it doesn't turn left or right. So that's the purpose of a key. So I'm going to come, we're going to offset down here. So there's a 5 coming down. And there's a 15. And it does not give you a measurement for the size of the space for that key. It doesn't tell you how far that key comes in. It just tells you that is a square. But when we take a look at the key, we can see the key actually looks like a rectangle. But what this means when we say that is a square key, it just means that the shape of it at the top will be that square. So we'll leave that there for now, and we will move on. Because the thing about the exam is, you cannot allow yourself to be stuck. There are many different parts that you can draw. There are many different things that you can do. So what I'm going to do here is, I'm just going to draw the spindle, or write the name of the spindle. This is only for the purpose of the video. If this were a CSE exam, I would not write the name of the video. I would not write the name of the part. So as I said, it's only for the video. So I'm just going to change my layers one time. And I'm not trying to do this drawing quickly. I'm just trying to take my time so that we can get through it. Alright, so I'm going to draw the piece above, which is the lever now. And I'm going to draw the lever. Actually, I think I'm going to draw the lever on the spindle. Because when I look at this spindle, we know already the spindle goes right into this lever. And there's a washer up here. The washer has a 3, and the nut comes on top of the washer. So the nut is 11. So that's 11 plus 3, which gives us 14. So I'm going to start the top of my lever right here. I'm going to start with this line, which is diameter 40, which comes across. So the question is, where am I going to put that diameter 40? And I'm going to put that diameter 40, this line right here, I'm going to put that right at the top of this. I'm going to put it right here. So let's do the diameter 40. Now usually with a drawing like this, I would draw this plan view first because that has circles. But once again, for the sake of the video and explaining the drawing, this is the reason I'm going this route. So I have a 20 to the left, I put a 20 to the right. So as we said, this is our 40. This is a top piece here. So now I'm going to come down 28. Now, when we come down 28, we realize that it is actually butting with the bottom of the spindle here. So starting at this piece may not be the best idea because it's not fitting. So what I'm going to do is I'm just going to bring it up a little bit. So I'll actually bring it so that I put it right here. So I'll just explain what I just did. So I started with the spindle. The spindle has this broad piece here of 32. So this 32 is a cylinder, is a circle. This cannot push up inside of here. The hole here is only 22. So when we pull the lever down on top, it's going to butt here, it's going to hit this side. So that's the reason that I made the adjustment, because the lever can't come down any further. So what I have done is the bottom line here has fitted right onto the bottom here, then the top line here is here. So that still works out perfectly. Alright, so I'm going to bring this up, which is the left side, bring up the right side, and we have that. At this point, I think I'm going to start my plan view now. Now many times when students complete drawings, they try to complete one view fully. It is very important to try to complete two views or both views at the same time, because it can help you identify errors, it can help you to clarify measurements. So all I just did was I started my plan view and I have not done any measurements on my plan view. All I have done is project down. So what exactly did I project down? I have projected down the 40 measurement that's here. Okay, so that 40 is the top of this. Now I know that this is a circle because it has diameter 40, even before I look at the plan view, right, and realize that there's no diameter on this. And the reason for that is the measurement is down here. There's also no diameter on the smaller circle. The reason for that is the measurement is down here, which is diameter 22. So because I drew the spindle already, and the spindle has a size of diameter 22, I don't need to measure diameter 22. I just projected it down. So let me just check to see if my measurements are correct. Diameter 22, diameter 40. So those two measurements are perfectly correct, even though I did not measure them. Alright, I'm going to, from here, we're going to go a little faster. Now, as I said, we're doing two views at the same time. It's important to realize that, recognize that. Alright, so I've just done the center. At this point, I want to put in the circle to the left, I want to put in the circle to the right. And the reason that I'm going to do those, because they're the easiest points to do. The first one here is 70 coming across the left, the next one is 60. So we just offset. $70 to the left. And then I'm going to offset 60 to the right. Now remember I said we're doing two views at the same time. So we have those. Now with that 70 to the left, there's several circles here. There's 30, anything I'm going to do, that's the 31st. So that's a diameter 30. And you realize that's in the wrong position, so I'll just move it. So let's just check the measurement to make sure it's correct. So it's diameter 30. And let's just check how far across it is, and it's 70 across. So the measurements are correct. At this point, I am going to project up. So as I said, I'm doing two views at the same time. So I have just projected up this left line, this right line. Now, there's a little piece that connects them, which is this 3. So I'm going to offset that 3. And just draw the line across. So I came up 3 here, okay? So the next thing is I'm going to draw in this piece, because this is a web. So there's a space at the bottom here of 3, and then that piece comes up 4. So I'm just going to draw that up at 4. Offset. And I think now I could trim off the bottom, because I have this web piece here, so I just need to project across the bottom now. And I can trim here. I'll also trim this piece too. Alright, so what exactly did I just draw? I just drew this bottom line here. So this bottom line here is 30. The little space that's in here comes up 3. And then this line comes right across, just about to the middle, right there about. This piece over here is 4. So we can tell that from the right side. Alright, so now, and I'm going to delete these projection lines, but you can clearly see they are coming up from this right circle. Alright, so I'm going to trim. And I'm going to do the right circle. The right circle there is 20. Okay, and with that diameter 20, so I'm going to project this up. We do the same thing as the left side. So we project this across. Now that we have projected that bottom piece across, I am going to trim out this little piece here, trim off the bottom, trim out the little piece here, and basically just trim out this piece. Alright, and the thing is, this piece comes straight across now. So I extend that. And what I'll do is I'll trim off this side. Alright, so we're beginning to put this front view in place to complete this drawing. So this piece is going to come up at 20, and it comes straight across to that piece. So we're going to offset 20, and we draw this upwards, and then we trim it going forward. So we trim off this top piece, and we trim the other remaining parts. So this piece will be trimmed, and we'll also trim off this bottom piece here. So as you can see, we are slowly filling in this lever. We have the left side here of the lever done. So we're going to go across now to do, well, we have the right side here of the lever done. We're going to go across to complete now this left side. So it comes up 20. So we offset 20 going up. And what I'm going to do is just trim off the top. So over here we have trimmed the top, and now it is saying that there are a few curves here that are being done. So before I do those curves, I'm just going to connect the top, and I have left out those curves. So we have the left side finish, we have the right side finish, and at this point we are going to continue now with the plan view. Now, as I said, it's very important to do two views at the same time where possible, so that you're completing what the question has asked for. So with this slanted line that we're using, the slanted line that we're using here is a tangent. So it is pretty difficult sometimes to draw in a tangent, especially when you're not sure where the line starts and where it ends. Simple tip, it has here, it starts from the center piece, so you can see that it starts here from the center. So we're going to click the center, pull across, and we're looking for tangent, that little circle. Now, if you realize that tangent does not come up on your computer, you will need to go into Polar, Tracking Settings, and you make sure that all of your snaps are on. You realize there's tangent here, and make sure your 3D ones are on as well. So then once you turn it on, it should come up. Project across the bottom, and we're going to come to the right side, and we're doing the same thing. Now the reason that I know that it starts from this point is because when I look at this front view, it stops around there. Now I'm going to do it slightly differently this time. I'm going to start from the front, pull it here, because we're looking for the tangent. And once I have found the tangent, I'm going to pull it back. Now usually we do this whenever you have objects like this. So you try to pull it back to find the other tangent. But with this drawing, it appears to start from the middle piece. So we come over here. So we have our tangent, and we're getting a little ways now with our plan view. I'm going to make this a center line. And let's look at the drawing. So there are a few circles that we're missing. And as I said, we're just taking our time to do it so that we can understand exactly what is being done. So I'm going to draw in this triangular piece, or this angle piece. Bottom piece here is 18, top is 14. So when I look at the plan view, I can see the smaller circle, which is a 14 solid. I can see the 18 in hidden. 14 is solid, 18 is in hidden. So we come here, circle radius. So I'm going to do my 18, which is radius 9. Come back, and I'm going to do 14, which is radius 7. So I make it, put it in detail at the same time. So that's the bottom. Now I'm going to project up. Remember, the bigger one is at the bottom of this piece. So just project up to the bottom, and the smaller one is at the top. So once again, we're killing two birds with one stone. So I project this up to the top, I pull it over here, project this piece. Remember, this is the 18, so pull it to the bottom. Then I'm going to project the top, pull it to the top, then I draw in the slant. So that's how we get the slant in, and I'm going to trim off these lines. I would delete them, but I just want to leave it to show you how we got that piece. And I'm going to put this in here. The same way we have it there in the front view. And as you can see, for the most part, this drawing is pretty close to what is here. So, alright, we have that left side. I'll delete this. And I'm going to continue from this left side with this slanted piece. And the reason I'll continue is because we have a tapered pin here with a lug head. And when I look at this, you would realize that it is missing several measurements. There's no measurement for the top here, but there is a diameter 19 here. Now if you look closely, this line is slanted, so this gets smaller coming up. Now the only space on this drawing that could fit an angle piece like this is this angle piece here. So how do we know this? It has diameter 18, also has diameter 14. So when we come and we look here, alright, just hold a second. So sorry about that. So as we said, this is the only piece that is angled. When we take a look at the other parts, the stud is not angled, and there are no other angle pieces. So the odds are very high. This tapered pin is going into this tapered piece over here. So without further ado, we're going to start from the top. So we're going to leave this piece, even though this does not have a measurement, you can assume that the top of this should line up with the top of this 14 here. So we're going to go from there. We're going to offset 21 coming down. And you realize that that 21 is a little outside of the drawing, which is perfectly fine. We're going to come now, we're going to offset 3. And remember that this piece here is diameter 19. So we offset again. Half of 19 will actually be 9.5. Put it on our left side, put it on our right. And I'm just going to make this solid so that I can see where the piece is. Trim. Now this piece here is a very small feature that I want you to start to do. Remember, I did that at diameter 19. Now remember that we are assembling the drawing. So I have just come from the front view and I'm going back to the plan view. And instead of wasting time, I'm going to draw in that 19. So we're not going to see that 19 from the top. So I'll just draw it as a hidden line. Alright, so I have my 19. And I also have it in up here. So for the slant, I'm just going to extend. Now you realize that this piece does look a bit odd. So I'm actually going to use extend to go forward. And we go from there. Now over here comes down 7. And we have a few circles. So there's a diameter 8, and it does not give you a radius for this. It's going to drop in the diameter 8. Now the reason that it does not give you a radius is because they have already told you the measurement of it. Over here it has diameter 19. So the measurement from this piece to this piece is 19. So the same thing goes for here. So the radius would have to be in 9.5. And we trim. So I'm just going to check to see what the measurement is. So we have our diameter 19. Alright. Now, from here, I will go to probably the plan view. Well, leaving at 19 first. I'll actually clean up this piece. And actually, before we go to the plan view, I'll just finish the top of this. So we already have our 21 in. We're going to come up 15 on our 2. Over here it has M10 by 1.5. So that 1.5 will usually represent the size of threads. So we offset our 5. And we trim. Alright, so from here, I'm just going to draw the curve. And I'm going to do it in the plan at the same time. Now, if you focus on this piece, we're actually going to see this circle. Because when we put on the nut, when we put on our washer, this piece is going to come right through the top of here. So I'm going to leave this solid. I'll put on the threads, offset 1.5, and I'll just put the break in it so we remember that this piece has threads. Now remember, there's no plan view. So because this piece is like a bolt or a shaft, the outer circle is going to be solid and the inner circle as well will be broken. Alright, so from here, you don't want to go too fast, but I'll drop the threads. And actually, I think I'll leave those to do the curve. And because this is higher than the left side, the curve is not coming out fully. So what I'm going to do is, remember it said you can do it at radius 3, but that is solely up to you. I'm going to come here, circle, radius 3, copy. Now this is a very small feature. This is not something that you have to spend a lot of time on. I'll just go over what I did with the second one. So I used the radius tree. I basically blended some curves just now to get in the actual curve that I want. So because I want a radius 3 circle or curve to touch these 2 points, I'm going to go with circle, come from the first point, draw a radius 3, and then come from the second point here, I'll draw a radius 3. And where the 2 of these curves meet, let me do a small circle first, like how we did with line the curves, and I delete these now. So because I drew these 2 curves from the points, this curve now will come back to meet those 2 points once I draw a 3 and it meets the 2 of them flush. Alright, so let me just trim this. So, and we could delete these lines. Alright, so we have that in. Now, the way this is drawn, they have it drawn so that, remember there's no measurement here, they have it drawn that this piece comes straight across and meets flush. And this is one of the problems with this drawing. When students draw it, it would meet flush here, but it would be bigger than the size. So what students would actually do, if you had drawn this piece separately, you could position it in such a way where it would drop down a little bit and it would meet flush. So instead of the way I drew it, where I drew it inside of the piece one time, if you had drawn this piece separately and dragged it in, you would realize that it will come a little lower so that this piece would meet back here flush. So I would just have to drop it down a little bit, but this can work. Alright, so from here, we're going to draw the washer. So the washer is down to 21. This is going to be solid. Come here from the center, 21. So we make this solid. And I'm just going to draw it, go up to the front. Now those lines may be too small to show the hidden lines in them. Alright, so we have our washer. They have a slanted washer which should give us 2 circles. Now we're going to draw the nut. The diameter of the nut is 18.5. So that nut, here's the size of the nut. Change the layer to outline. And let's draw our hexagon. So because the diameter of the nut is 18.5, it means that we have to inscribe this nut. We cannot circumscribe it, because if you realize it's circumscribed, it's coming out of the red circle. So now we come to the red circle here, and that is our nut. Now remember, since it is a nut, we need to put another circle here on the inside. And we can delete the 18.5 now. Alright, so we have our nut solid. I think this hole we're not going to see anymore now, so this has become hidden. And I'm going to project the nut upwards. Height of the nut is 8. And we're going to project our bumps. Offset is about 2. 2 looks a bit big though. And then we just going to trim off this top line. Also going to trim the bottom. Redraw the top line so we can have our centers. 1. And now our 3-point circle. Alright, so we have in our nut now. And I'm just going to trim off these excess lines. And delete them. Alright, so this left piece, we have the top view finish. Come down here to this bottom piece. Now the way this piece is, with this tapered lug head pin, this might be a rectangular piece in the bottom, but because they do not have an alternate view, I will just use it as a rectangular piece. Remember, it said that you can average the measurements. So we have the lug here in the bottom. We have, remember, this is the washer, so we should have a hidden detail line coming across for the hole. Which is the hole in the bottom of the drawing. So that's our hidden detail for the hole. And then we're going to project the left side and the right side. And I'm going to leave it as a rectangle. So I'll offset, maybe put it offset about maybe 3. Put these as solid lines. I'll put them as hidden detail lines. And this here is hidden detail as well. Well, actually, all of these are hidden detail. Just a matter now of trimming. And now we just delete the rest. So the left side of this piece is now finished fully for the most part. We just have to trim here. Alright, and we're just going to put this as a center. Whenever you have a center, you try to extend it a little outside of the drawing, similar to what the questionnaire has. Alright, so the left side here is done, and we have that assembled. We're going to come now to the right side. We already have the spindle in place. We just have to put the nut on top, and funny enough, the drawing is actually almost finished. We've done most of the work with that left side. Alright, so here we're going to put the washer and the nut. So I'll do those a little faster, and with this I'll just draw. We're going to see this piece here sticking out, so I'll come down and draw that circle. So we offset so that we can have our threads. Same thing as the other one. Trim the outside. Because it's a shaft, we'll actually trim the inside. And now from here, we draw out the threads. Now the reason why I did this first, because remember I said we are going to see, we're going to see this piece sticking out at the top, and that's important for the end. So you don't want to have it in a position where you have to do these small things at the end. And as I said, we're going to go a bit faster. So from here, washer, diameter 36. And that's a huge washer. So you'll definitely see that at the top, and project it up. That 36 comes up 3, then it comes across. And we trim. So we do our nut 24.5. Actually, that is diameter 24.5. Remember, AutoCAD will not do the half measurements, so we're looking at this big circle here. Center, inscribe. So we have our nut, delete, and then we draw our small circle on the inside. And the two of these are solid, because we can see these from up above. as usual, we project upwards. Now I don't have to draw new lines all the time. I can just copy. You just need to make sure that's long enough. And from here now, the nut there is 11 offset. And we're going to draw in the top of our nut. So we have a few bumps here. I think I put the first one at 2. So I'll put this one at 2 as well. And just go over this line. And we do our bumps now. So you make sure it's the right line. And with this, the line should be here. So this center here is a little off. So we do our 3-point circle, make sure that you have the correct points, and then we trim. Alright, so we have in our nut, and you realize that the nut is in the front view, the nut is also in the plan view. I think we are missing 1 or 2 hidden details for these circles. So we just come down here. Okay, so we have that one, which is supposed to be hidden. And let me just check the piece at the bottom. We should have a circle here, which will be hidden as well. And we will also have, remember, a circle for this piece, which is all the way at the bottom. And this is going to be hidden as well. So those pieces that I projected down were parts of the spindle that we would not be able to see because they're in hidden detail at the bottom of the piece. So now we come over to the second last part. We're going to leave the key for last. Remember, the key is going to come into this slot here, and we will draw that key from down here. So over here we have our stud is M10 by 15, so immediately know that the space in here is 10. Offset to put in our threads. And you put in your brick. when there is no, when the second part with the threads is not put in, you would not put in your bricks. But I'm just putting these bricks in here so that you remember. If it's separated, you will have your brick in, but once the two pieces come together, you will actually not see the little break that we'd usually put in. So I'm going to leave this off, leave the break away, and I'm just going to put this in as solid. I'll just go over that again. If we were looking at the stud by itself, because it has threads, the outer circle will be solid, the inner circle will be broken. If we were looking at the lever, the inner circle will be solid, the outer circle will be broken. But once these two pieces come together, you will not see any breaks. Alright, so over here, we just draw these out. And the entire height of it is 28. So I think I'm gonna just put it in the exact middle. So we offset 14. And we trim. Offset. No, I offset at 1.5 because it has here that is M10 with 1.5. So I offset 1.5. 3 point. And I'll delete the middle one, yeah. So here it's a 10, 10, and 12. So I'll offset 12. No, because there's no horizontal, it's only showing me the position of the center. So I'll just draw a light line across. So offset 12. And then we offset our 10 from the bottom. Now you should have 2 nuts to put on this piece. Now these should be 45, but that does not look like 45. So I'm just going to set it to 45. I think they may be drawn at 60. Right, and so we have that in. Do they have some nuts missing? Rotary lever, third angle. No, they don't have any nuts missing, but you should have a nut to put on the top of this and a nut to put on probably the end of this. Alright, so the last piece, which is the key. As we said, there's no measurement for the key. They don't have the space over here. They only have here that it is 15, but they do not explain what is the size of it. So what do? We come here, offset 5, 5 to the left, 5 to the right, trim, and we extend, trim, alright, so there's our key. I think I put it a little bigger than what it should be, but it's not a problem because they did not give you a specific measurement for it. So I'm going to come down here now, and it's important to finish off this piece because it does have a little cutout here. So remember the hole that was here is a 22, so I'm going to look for that 22 hole, which should come from here. And then I'm going to offset 5. Basically the same measurements that I use above. And I just trim and clean it up. And I just draw on the other side of it. So we have the key. As I said, the size of it is probably a little big. Maybe I should have done it at 3. But because it is really up to your discretion, it is not a problem. Now, we would see the right side of the key here. Well, actually, no, we won't, because the washer is going to block it. So all of this key is going to be in metal. Now, the thing about the exam is, you answer the question to the best of your ability, and the instruction that they give regarding if parts, or if you're unsure about specific parts, that is something that you have to remember going through the exam. The last thing is, it says a sectional front view on XX. So I'm just going to drop in my leaders. Now usually when you do a leader, you want them to be the same size. You want them to be the same space. So I'm going to offset about 5 off. And I'll just drop in a leader. So it says XX. I have not even looked at where XX is. Okay, XX is here. Alright, so we got in our cutting plane. Now the thing is, because the cutting plane is right through, we already know what should be sectioned. This key is a fastener, so I'll start with that because it's cutting right exactly through the middle. So I think maybe I'll start with the left side. So what has happened, all of this in here will be removed. We're not going to see this. We will not see that. is that over? I think this piece has to come around. Will we see this? No, we won't. This piece becomes solid. Outlines. The web that was here will be gone. And you see that piece, you come over here, your web is going to be gone. We will see the inside of this piece full. We'll see our rectangle here fully. And you will see this piece here fully. Actually, I deleted the nut. This piece in the background is what will move because the nut will not be cut. Also, the washer will not be cut, so we'll see top here. And we go over this side. As we said, this is going to be solid. You'll not see this web anymore. Comes across here. And in here is going to be solid. Now, if you can realize from the beginning of the drawing, if you realize what is to be sectioned and what will not be sectioned, then you don't have to draw in these things fully. The reason that I drew in these things fully for the video was because you are watching it and I want you to understand fully the assembly, but at the end of the day, we still need to remember to answer the question. So in this video, the reason that I've just taken my time to draw it through is so you can see the full assembly, but as we're coming down to the end, I have done the full section. So in here, we get our hatch tool. Oh, I think I'm missing a line. This line should come straight up. And you also see this line from behind. You'll also see this line coming up a little bit. So we're going to hatch. Section, section, hatched, and hatch. So we have in our pieces now, pieces that will not be sectioned. So for the most part, that is how most of the section will look. And we have our cutting plane at the bottom. We just label the views. And since it's CXC, you want to, oh, we forgot this one here, this diameter 4. Offset 2 up, 2 down. You'll probably see some hidden detail of it underneath. Alright, so here is the web that you can see from the top. Here we need to change layers, but also we need to show some of the main dimensions, and you try to use several main dimensions. So I'm going to put in 2 from here. This is the 70, and I'm also going to put in the 60. Then you want to try to show an end measurement. So I'm looking at the drawing to see if I can find any here. Alright, so we got M14. I'll probably do that one for the bottom. M14 by 2. And now you want to put in the circle. So I'll put that down to 30. You also put the down to 20 from your left side. And I think I'll put in another end measurement. So we have here, not going to use that. We'll do this M10 by 1.5. So use a leader for this one. Alright, so we have our dimensions. And we'll drop in our scale and our symbol. Alright, so we have our first angle symbol. I'll put in the scale as well. So because with this drawing we did it the same measurements. So scale will be 1, 2, 1. Scale 1 to 1. and we also print the title. And you make sure your spelling is correct. So, last thing, make sure that these layers are correctly done. So once we change the layers, that'll be it. So as I said, just taking our time and going through the drawing. The most that I have is given a bit of problems, so it's misclicking at different points, which is not a problem, but you just have to take your time and complete it. So with this drawing, remember we just went through the full assembly so that you can see not only how the parts are put together, but how you can get this drawing done. It's not something that is beyond you, but it's something that you will have to take your time and just do piece by piece. CXC is not looking for you to have a perfect assembly. They're looking for you to answer the questions. So when we talk about answering the questions, show the assembly, show the parts that are assembled, show the section, and you will get your marks. So it's just important that you make sure that those are the things that you do to get your marks. So all of this tidying up. Excuse me. Also try to delete those double lines that you have in place. You don't want to leave those double lines in. Once those double lines are in, they can show up once you print the work, and they will look thicker than the other lines. So it's just important to make sure you do not have those double lines in. It's just a matter of rechecking. Sometimes you may forget one or two, but for the most part, they're not going to take off many marks for them. Now, make sure that your hatch is also on the correct layer. You don't want it to be a situation where you are losing marks. Well, you're losing easy marks. So, if your hatch is not on the correct layer, you just make sure you set it to section lines, and you hatch. Alright, so as I said, for the most part, this is what a drawing will look like. This is what the assembly will look like. Now, this is a pretty complex drawing. It does have, though, some very simple, basic parts, which you should be able to complete, you should be able to cover, but because of the number of parts it has, that is what makes it a bit challenging. So just make sure you remember your basics, you have your center lines, you have your scale, you have the title, you have your symbol, you have your 6 dimensions, 1, 2, 3, 4, 5, 6, you have 7, probably delete this party. So, and then you have your assembly. Check your layers to make sure that they're correct. And as I said with this drawing, there's no rush with this drawing. We're just drawing it so that you can understand how it goes together. So at this point, I'll stop the video. We'll go back here to the question. We drew it in first or third, and I have the symbol different because I drew it in first angle projection, which is what we should have it done in. Right, so we have our sectional front, we have our completed plan, and we added on the remainder of the questions that are answers CXC. So when you attempt this drawing, when you try to get this done, make sure that you just take your time. You have time now to work on it. So take your time and do it to the best of your ability. Giving up, if you do give up, you have basically conceded to 0. But if you try to push through with it, just piece by piece, you will slowly get there. Imagine if you're walking up a long hill, you may have to take breaks or pauses in between. But at the end of the day, there are many different components here that you can draw. So don't give up, don't quit. Once you quit, you have conceded to 0. So that being said, practice. You can speed up the video, rewind the video, it's up to you.